So we've recently learned that the number system that you've been using for most of your life is called decimal, and you're very fluent and comfortable using this system, but it's still worth taking a closer look at how this number system works. So the important element of the decimal numbering system is that it is a base 10 positional system, and that means two things. First, there are 10 symbols. There's this sort of fat, round one that we call 0, and this tall, thin one that we call 1. There's this one that's flat on top and round on bottom, and we call that 5. And each of these symbols is associated with a value. Again, you're very fluent and familiar with this. You know that this one that we call 5 is associated with the number of fingers on my hand, and so on. And the second thing that this base 10 means is that these symbols are arranged in columns which are powers of 10. By convention, we put the ones column on the right, and subsequent columns are just multiply the previous column by 10. 1 times 10 is 10, times 10 is 100, times 10 is 1,000, 10,000, 100,000, a million, and so on. And to encode a number in decimal, we just put one of these symbols in each of these columns. And the amazing thing about this numbering system is that with just these 10 symbols arranged according to this pattern, we can represent any number. And we can take a look at that. So, for example, I have here two dice, a little purple die and a green die. And if we look at these dice, we see on the purple die, we can see 3 faces on this die, and we can count the pips on each of those faces. There's 6 here, plus 5 is 11. Plus 3 more is 14, and on the green die we can see 4 more is 18, there's 2 here, 19, 20, and this last pip. There's a total of 21 pips that we can see on these 2 dice. And we can represent that value, 21, in the decimal numbering system by placing these symbols in these columns. And so we would ask ourselves, well, how many 10,000s are there in this 21? And of course there are 0 10,000s in the 21. And of course there are also 0 1,000s. There are no 100s, but there are some 10s in there. So there's this 4 plus 6, that's 10. And then there's this 3 plus 5 plus 2, that's 10. So there are 2 10s in 21, and we can represent that with this 2 in the 10s column. And that leaves 1 pip left, and we can put a 1 in the 1s column. And so we get this representation of the value. The number of pips on these 2 dice, 21, can be represented as 2, 1 in decimal. And you'll notice that these leading zeros have no effect on the value. Now you may be thinking, well, what about negative numbers? Surely we would need a minus sign for negative numbers. Or what about numbers with a fractional component? Surely we would need a decimal point to represent those values. And in truth, we do use a minus sign and a decimal point as a convenient notational device. But in reality, neither of them are necessary. We can find a way to encode any value, positive or negative, whole or fractional, with just these 10 symbols arranged in columns that are powers of 10. I'll leave that as a challenge for you to consider, and we may come back to that later. But right now, I think it's just amazing to realize that with just these 10 symbols arranged according to this pattern, we can represent any number, an infinite number of numbers.